One of the big topics in algebra is the concept of a function. A function is a one-to-one rule between two variables. Now, what does that mean? Often, if you go in your algebra book, there will be like a picture of some machine, okay? And we put numbers in, and then numbers come out. So we put numbers in and numbers go out. So maybe every time I put the number x equals 3 into this machine, maybe there's an output of 5, and we call that maybe a different variable. It's called the dependent variable, maybe y equals 5. So let's keep a table up here of our observations. So 3 goes in, 5 comes out. Well, let's try putting in a different number. Maybe 8 goes in and -1 comes out. So we'd have 8 and -1. And let's try one more combination. Maybe we put -5 into this machine and out pops 1. Now what if I went back and I put 8 in there again? What's going to happen? It's going to spit out -1. That's what's meant by one-to-one. Every time I put a certain number in, it's predictable based on some sort of formula. The same output happens every time. You can imagine if I put 8 in and then 2 came out the second time, that would be really confusing. You would feel like the machine was broken. All right, so a function is very predictable. Every time a certain number goes in, the same output happens. So inputs and outputs are combined together. So I have an example here. Y is always 3 more than twice x. So y is always 3 more than twice x. So you can imagine if I put, let's do a t-chart on that. If I put 1 in there, if I put it right there, what's 2 times 1? That's 2 plus 3 is 5. So we put 1 in there, we get 5 out. If I put 0 in, I get 3 out, right? 3 plus 2 times 0. If I put -1 in, I get 1 out. Every time. I could go back, you could keep watching this video over and over, and every time we put 0 in, we're going to get 3 out. So this is called a function because it's one-to-one, so every time a single input goes in, a predictable output happens. And it's that concept of a machine that just consistently does the same thing over and over. So functions have graphs, as you've learned this year in Algebra 1 so far. And these graphs represent all the input and output combinations that work in this function. So this point right here, it looks like it's 2, 4. So every time 2 goes into this function, we could call it f, 4 comes out. And I get that information off of the graph that I'm looking at right here. See, every time -2 goes in, it sure looks like 4 comes out. So those are ordered pair. By the way, -2, 4 is an ordered pair. It's x, y. We always write that x coordinate first. So it's an input-output combination for this function f. Now on the right here, we have another graph, and this is not a function. This is not a function because it fails the vertical line test. Let me show you what I'm talking about here. You see this dot right here, and this dot right here, and this dot right here. You see how they're all lined up vertically? They're on top of each other. That's how you can spot when something is not a function. Because, check this out. If I put 3 in, I have 3 options that might come out of this relation, it's called. It's a relationship. It's not a function, so I can't use the word function with this. So it looks like, if I go over 3, it looks like up 3, right? So that's one option, or maybe up about 4, and then up, let's count this carefully. If we go over 3, up, how many is that? That's 3, 6, 8. 3, 8 is another possibility. This thing fails the vertical line test because there are points on top of each other. So that indicates that we might get multiple outputs, and that's a problem. Whereas the graph on the left, if I draw a vertical line, it only hits once. If I draw a vertical line anywhere, it only hits once. That's how you can spot graphically if you've got a function on your hands or not. It's called the vertical line test. So these x values are not allowed to repeat and get different outputs. So that's how you can spot If you're just given some points, you can spot whether it's a function. So, for example, is this a function, question mark? If I write 1 comma 3 and then 1 comma 5 and then 2 comma 8, is that a function? The answer is no, because 1 goes in, we get 3 out. 1 goes in again, we get a different output out. So the x's are not allowed to repeat and get different outputs. Okay, so this would be no, this is not a function. We have function notation. So this is pronounced f of x. F of x. That means a function f composed or made up of the independent variable x. So this is where we put our inputs in. Okay, so the x tells you where we put things in. So f of x means we have a function, first of all, it would pass the vertical line test, and this is where we would put our values in. So this is pronounced g of x, this is pronounced h of x. So then, down below, when I ask you to find or evaluate f of 1, what does that mean? That means you're going to put x equals 1 into the function. So the function f is x plus 3. So we're going to use that function. So we put 1 plus 3, that equals 4. So we would say f of 1 equals 4. And by the way, as an ordered pair, that means that 1 comma 4 is on the graph of f. Now off to the right, I've got g of negative 1. Well, see, the advantage of this notation is you know instantly which function to look at. You know we're talking about the g function this time. So we do 2 times the input minus 1, because remember, this is where we put numbers in, right there. So what are we putting in? We're putting negative 1. So that's negative 2 minus 1, that's negative 3. So once again, the point negative 1 comma negative 3 would be on the graph of the function g. Now the function h is a fun one. It squares the input. You see how we put numbers in here. Whatever the x value is, we put it in. So this would be 2 squared, and that's 4. Now what about h of negative 3? Be careful here, folks. Remember what I talked about earlier? Negative 3 squared, if you type that in the calculator, it's going to say negative 9. But yet we are squaring, remember our x is negative 3, so you have to put parentheses. We're squaring the negative. We get positive 9 this time as the answer. All right, and on the next one, I like to color code these. So f of g of 3. You see how it's like Russian nesting dolls here. We've got a function inside a function. So you start from the inside and you find the answer for g of 3. So you come up here and you plug 3 into g. That would be 6 minus 1, which is 5, right? And then in part 2, you then take that output and you put it into the f function, and what pops out now? We get 8. You are literally connecting two machines together. So we started with the g machine, we put 3 into the g machine right here, and out popped 5. We then took that output and immediately put it in to the f function. 5 plus 3 is 8. Now down below, I'm putting one function in the other function entirely. Remember what the h function does? This is called a composition of two functions. The h function over here is the square function. What are we putting in? We're putting g in. And look at this, I'm even making this really tricky. I need to put t in for x. So there's your answer. I just composed two functions, it's called, where you nest one function inside the other, and I even replaced the x with a t because that's what it said to do. It said to write g of t. So this would be my answer for h of g of t. Function notation. You're going to be using this all the way to AP Calculus and beyond when you're a math major in college, right? We can also read values of function notation off of graphs. So here we have a crazy graph down below. I don't even know what that function is, but it doesn't matter. We can read this information off the graph. F of 2 is. So what that means is you go over 2 and you figure out where the graph exists. So if I go over 2, I'm right here, folks. I'm right here. This is the point 2 comma 5. So that means f of 2 is 5. I can read that off of the graph. What about negative 1? Well, I go back 1 and I go up, that would be 2. What about 0? I go over 0, I go up 3. That's what the graph says. See, a graph is a picture that shows you all the XY combinations that work. F of 7, let's go. There's 3, 7 would be right here. That would be a 1. Okay, for what values of x is f of x equal 1? See, now this is tricky, folks. This is where the y value is 1, and we're asking what x values satisfy that. Well, we have to go to y equals 1 and imagine drawing a horizontal line here. That's y equals 1. And we have a point right here, we have a point right here, we have a point right here, and a point right here. So there are 4 x values. So for example, you might say, let's see, 1, 2, 3, 4, 5, negative 5.7, right? Negative 5.7 looks like one of them because this point right here. 6, 7, 8, 9. Maybe negative 9 is another one. Looks like 4 is one of the x values, and then also 7. Right, you see how we did that? We used the line y equals 1 to find the x values that could generate the output of 1. Because that's, again, what you're asking is you're saying, we've got this machine, f, when does it output 1? It would output it at those 4 different values. All right, until next time.